Okay, so this is the 2016 paper, question 7. This is a nice question, brings together lots of things to do with heat. Heat. Right, at a lecture in Cork in 1843, James Joule, while describing his work in heat and temperature, suggested the principle of conservation of energy. Later in the 19th century, the work of Joule and Lord Kelvin, go on the Irish, led to the invention of the heat pump. Distinguish between heat and temperature. Okay, fairly easy one to start with. Heat is a form of... Oh no, geez, what am I talking about? Energy. Heat is a form of energy, and separately, temperature is a measure of the... You can say the hotness if you want, but that's a weird thing to use. Heatness, no, I got confused there, of the heat energy. And then in brackets you could say hotness of an object. So it's a measure of the heat energy or the hotness of an object. Okay. State the principle of conservation of energy. That's nice and easy, hopefully. Energy cannot be created or destroyed, but can be changed from one form to another. Okay, can't create or destroy energy. Perpetual motion machines do not work. Thermodynamics is a thing. You can't, yeah. Okay. As part of his presentation, Joule proposed that the temperature of the water at the bottom of the Niagara Falls would be 0.12 degrees Celsius greater than the top, due to the gravitational potential energy being converted into heat energy. Okay, so this is interesting. We have a change in temperature at delta theta, which is what we always mark them as, 0.12 degrees Celsius or 0.12 degrees Kelvin. Calculate the height of Niagara Falls. Okay, so he's saying that the potential energy, let's write down any formula that we might use, it's going to change into heat energy. We also have a formula for figuring out how much heat energy can be absorbed, and that is mc delta theta. Okay, so what does it say? Calculate the height of the Niagara Falls. Okay, so there's our height. It's going to fall a height, and he's saying that this energy is going to be converted into a heat energy. So the potential energy is going to equal the gain in, let's call this heat energy. Okay, so potential energy is mgh. mc delta theta is the heat energy, and this is handy because we don't know how much water we're talking about. All right, so the fact that there is the mass is on both sides means I can divide both sides by mass, and it's gone. I'm looking to figure out what h is, so that means it's going to be the specific heat capacity of water multiplied by the change in temperature divided by the acceleration due to gravity. So we are, what numbers are they giving us? 4,200 for the specific heat capacity, 0.12 for the Kelvin, the change in temperature, degrees Celsius, whatever you're having yourself, and they tell us to use 9.8 meters per second squared for the acceleration due to gravity. So 4,200 times 0.12, divide that by 9.8, and I get a height of 51.4 and a bit. Let's go 4.3 meters. That was like 2 decimal places. Okay, there we go.